Great. So today I will be sharing some of the work that I've been doing over the past year since I joined the Uber Eats team. I specifically focus on the shopping experience. So as an eater, when you're going through the ordering flow. So I'll touch on some of the problems that we tackle. And this is going to be a pretty high level talk, but hopefully I offer something interesting. And I'll start with a little bit about myself and then some background on the Uber Eats and shopping space. And then I'll spend some time talking about experimentation, which is a really big part of how we iterate on a lot of our features. And I'll go through a case study with one problem in particular. So Kelly's already given an intro on me, but this is a quick slide summary of where I've spent my time over the last few years. So yeah, I'm a data scientist at Uber Eats now. I've been here for almost a year. And before that, I got 2 cats, which are my babies. And before that, I was at Shopify and I did my master's with Kelly. So stepping into the Uber Eats space, I'm sure a lot of you are familiar with food delivery apps in general, and maybe the Eats app specifically if you are an Eats fan, hopefully. So there are hundreds or thousands of options to choose from at any point in time, depending on where you are in the world, if you are downtown or if you're in the suburbs. There's about over 50 years per day across all of the Eats, across all of the users of the app who are just browsing through the Eats app and scrolling. And the reason for that is there are multiple restaurant options, there are multiple dish options, and a lot of the time you might have trouble picking different options. And part of the mission of Uber Eats is to make eating well effortless at any time for anyone. I did have to look for this mission, but I think it does align with what my perception is of what some of the problems are that we're looking at, where we're trying to focus on making it easier for you to order at any time. So a property of the problem space that we have to keep in mind when we're working on any kind of problem is that the Uber Eats ecosystem is a 3-sided marketplace. So we have, we think about it as 3 different players in this space, where we have the eater, we have the restaurant partner who's supplying the options, and then we have the delivery partner who is obviously bringing the food to you. But between these 3 different players, there are 3 different objectives, and sometimes they are objectives that conflict. And so oftentimes we are from the perspective of an eater. So we think a lot about how eaters care about, the problems that we care about related to eaters are things like whether eaters might return to the platform, whether they're having a good experience. When thinking about the couriers, we're thinking about supply reliability at different times of the day. And then with restaurant partners, we're thinking about fairness and earnings for restaurants, and making sure that we're giving restaurants equal opportunity and equal access to the eaters, because that's a source for them. So keeping all of this in mind, these are the 3 kind of main players that we have to think about. So this is an overview of kind of the flow through the app. And this is the main problem space that I have been focused on. So when you open your app, you can you scroll through and you're presented with a set of restaurants near you. and you might browse through the feed if you're feeling curious, or you might have, if you're picky, you might have some particular intent and you might go to the search bar and search for a specific restaurant that you have in mind. So we call this whole space the discovery experience space. This is a lot of dealing with how we present to you different cuisine types or different restaurant types, depending on the profile of how you browse. There are a whole suite of problems that we have to think about in this space. For example, going back to the idea of restaurant earnings, we want to make sure that restaurants get a fair chance to be displayed through the app. The real estate on mobile is quite small, and so depending on how we rank the restaurants to you, that influences a lot your behavior and your choices, because oftentimes you don't end up scrolling all the way down. You're probably very much going to be biased towards the items that are shown at the top, or the items that are recommended to you. And so thinking about that in our ranking problem is one space that people are working on, to make sure that we're not only recommending restaurants that are relevant to you, making sure that we give a fair chance at diversity, diverse options. So that's one problem space. And then we kind of think about the other side once you start entering a storefront. And from that point on, we call this the shopping experience. So once you enter a storefront, similar to the feed, there's now a set of dishes that you have available to you. And we want to make sure that we are recommending the best dishes that are relevant to you from that storefront, and help you in crafting your cart. And so you might go through the menu, look at specific items, customize those items, add it to cart, and then check out. And that's kind of the happy path. If you end up going through and it's a very seamless process. A lot of the times though, and part of what makes food choice hard is that you might not be sure about the dish choice, you might not be sure about the restaurant choice. And so I know that when I'm ordering, I go through and I look at the food descriptions. I base it a lot on photos. I might go back and forth between different restaurants, or I'll even refer to other sources off of the Uber app. Like I'll go to Yelp and look at reviews there as well. So part of the problems that we're looking at are how do we help people order with confidence more, and make it more streamlined so we can better present to you items that might be more relevant to you, or more novel to you, but then also give you as much information as possible to be able to make your decisions. For example, we might badge things that have a history of being high quality, or restaurants that are high quality, which gives you a little bit more information so you don't have to start going back and forth throughout. So that, and going back to the mission, that's part of us trying to make this experience more seamless. So that's an overview of the key steps in the ordering process. There are so many different things that we can try to help help improve that ordering experience, and it can be tricky to figure out what to try, how to try it. And so a really big part of our work is experimentation. Experimentation is a really, really strong part of the culture. It helps us move quickly because we can get clean signals on different features that we're testing out, and make sure that we get a clean read based on our key, whatever the key metrics are that we're trying to test out. One thing that is really important as well for us to keep in mind is that, so going back to the fact that this is a three-sided marketplace with different objectives for different partners, this helps us understand if we roll out a feature, how it impacts all the different parties. We also operate in multiple cities around the world, and different cities have different network effects. And so getting a sense of localization and how different features might impact different areas around the world is really important to us. And then also, we're always growing and we're always moving. So a big part is just making sure that everything that we test is clean and that we understand the read. And that helps inform us how to proceed in the next steps and what promising areas there are to update any experience. So we do a lot of experimentation in the space of the shopping experience. We do a lot of A/B testing. So with A/B testing, as long as we make the assumption that there are no network effects, we basically present two different experiences to eaters that we've shuffled into control and treatment, and we'll test based on whatever key metrics we might have for that feature. We look at how that compares between control and treatment. Things we have to keep in mind are whether there are network effects or not. So A/B testing works in a lot of our environments, but sometimes if we anticipate there are network effects, that might impact both the control and treatment. We have other types of experimentation that we might do. For example, we might do like city by city and have sister cities act as a control and compare performance that way, or alternating windows of time. So there are different strategies that we might take. But it's really important for us to get this right because it gives us a clean signal and gives us clean learnings. So we also need to think about any bias in the user groups that we're doing the testing on. We need to think about specifically whether eaters are actually exposed to the treatment or not, and try and avoid any kind of dilution to make sure that we get a clean read. And mainly the purpose for us is to figure out, it's mostly like a learning opportunity. So even if we don't see positive results, it gives us a sense of how users might be engaging with the different features that we're testing out, and then figuring out the good and bad parts of the features that we test out. So looking at where people might drop off, so where the feature introduces the most friction, and then we might adjust accordingly. Or if we're introducing something into the menu space, whether it is cannibalizing the behavior of some of the other features that we're testing out. And these aren't necessarily good or bad, it just gives us learnings to figure out how we can iterate and really understand what's driving the behavior of eaters. And so I found this slide. This is kind of best represents how we do these cycles. I know this is really high level, but is a good snapshot of how we look at identifying some problem and then doing a lot of prototyping and a lot of iterating to before we start doing any kind of refining. And the type of things that we might test out are in the menu space, whether it's a badge on an item, that might be a feature, or if we're introducing a recommendation section, that might be a feature, or if we're changing the ranking model, that would be a different feature. And so all of these are things that we test. So I'm going to step through one example that we've been looking at over the recent period of time. So when you go through the app and you're ordering, I think I mentioned in my breakout room, my favorite food is tikka masala. Very true. And the scenario that we have as an example is, let's say you're going through and you're ordering tikka masala, and you add it to your cart and then you place an order and then you realize that you forgot the rice. This is kind of our hallmark example of what we want to try and avoid. We want to make sure that we are helping remind you of the full set of recommendations, the full set of dishes that you might be interested in that might help complete your meal to avoid these scenarios where you might forget side items. And so this is the problem that we have. And in framing the problem, we want to make sure that we're recommending dishes that are relevant to you, the eater. But we also want to make sure that what we're recommending is complementary to what already exists in the cart. We don't want to remind you of ordering something that you've already added to your cart, or we don't want to recommend something that maybe doesn't pair well. If you've ordered a burger, we should ideally recommend you fries and not carrots, or maybe that's a good pairing. Yeah, who's to say? But starting with this problem, one thing that we might do is we're not sure whether that's a valuable feature or not. Maybe people prefer to be in control of crafting their cart, and they might not want to respond to any kind of recommendation. So we might start with something rule-based. For example, we might say something like, we'll only recommend sides to you. That introduces its own set of problems. For example, do you have a semantic understanding of what a side is or what an entree is? And you might not, and you might have to build out some sort of taxonomy and do some sort of labeling on the dishes that you have. Or you could approximate that based on price. A lot of the times prices or sides are maybe cheaper, so you could take like the bottom 10th percentile of prices in that menu and make recommendations based on that. The one thing about this approach is that it is limited in the specific use case that we have set here, which is that you might be, that it's sides that you're forgetting in completing your cart. But there are obviously multiple different kinds of eater profiles. Let's say in the pandemic time, you're often ordering for a household. And so you might be thinking about not forgetting multiple different entrees based on the number of humans that you have in your household. And so your eater profiles will change. And we basically want to make sure that the ideal end goal accounts for all of the different use cases. But this is a good first step in just getting through the door a sense of do people benefit at all from final recommendations before we start improving. But we do ideally want to work towards personalization. So some of the work that we've been doing is building out a model to try and predict the most relevant items that pair well, both with you, the eater, and your history of orders and how you have ordered in the past, either on that restaurant or on similar restaurants of that style, or based on similar eaters to you. And we also want to make sure that that's complementary to the items in your cart. And we have experimented with different models that make these recommendations. So we might end up recommending these top 5, and then we'll present that to you. In understanding working towards that objective, a big part of what the work involves is also just thinking about how we craft the features and making sure that they are features that best represent what the problem is. So we want to make sure that we're representing eaters well and thinking about how we represent those eaters' taste profiles or their order history or similar eaters of that style, or your browsing patterns, whether you're more novel in the types of foods that you order or not. And then also thinking about how we represent the dishes. So are the dishes that are the candidate dishes, ones that typically convert with other dishes. So sides would be one that typically isn't ordered alone. Or is it something that's maybe more standalone, or thinking about the distribution of the price? And then also the different contextual features of the time. My favorite example is when I'm ordering at dinner time, I want to be recommended foods that are relevant to, or that are dinner foods. But then when I open the app at 10 p.m., that's usually when I want bubble tea, and I want to be presented with bubble tea, and that usually is what happens. Or depending on the different city effects or the day of the week. Of course, there's a lot of seasonality within the day and within the week. So being able to capture that. And then we also want to capture how the eater affinity for different dishes or different restaurants. So whether eaters have in the past given high ratings to certain dishes, or whether they've ordered from a specific dish a lot. And then also thinking about how complementary dishes are to each other. So whether they're frequently ordered together or whether they're similar cuisine types, things like that. So that's a really, really brief overview of how we structure that problem. Some of the fun challenges we have to think about are the fact that a lot of the times dish data dish data is sparse, and co-occurrence of multiple dishes is even sparser. So we have to think about how we generalize to all dishes. We also, as I've mentioned before, have competing objectives sometimes. So if our goal is to have eaters return to the platform, or to have eaters have novelty in the recommendations they have, those are kind of conflicting tasks. And so what we have in place is multi-objective. So we have different models for different tasks, and then we have a layer that weighs the different objectives, and that ultimately determines what the final recommendations are for a specific eater in some context. The other thing is that latency is really crucial. We obviously, scrolling through our phones, have a certain expectation for performance of the pages, and if things take too long to load, that's a really bad experience. So having personalized models can often be costly just engineering wise, and so we have a great set of engineers that tackle these types of problems, but from our perspective, when we're building up models, we need to make sure that the models that we have are lean. We shouldn't just throw in all different features that we can think about, but make sure that they're ones that really best represent the input space towards the final objective. So we do a lot of iteration and offline evaluation to make sure that the features that we have are both important, but also don't negatively impact the model performance. So that's a trade-off that we have to make a lot of the times. We also, based on the recommendations we give, definitely bias towards the options that we present to eaters, because real estate is really small. And something that we have to account for is the fact that we might just be reinforcing the recommendations we're offering. So we need to, some of the work that we're doing is looking at trying to address that bias and make sure that the options that we're recommending are actually relevant and not just reinforcing our own model. And another problem space that we're also looking at is whether these are the recommendations that we're offering are incremental, or if we're just cannibalizing another experience, because building out a model requires a lot of engineering cost. basically want to look at making sure that it's incrementally valuable. So let's say we're just taking the top most popular items and recommending that in its simpler form, which doesn't require any sophisticated modeling. Will our model perform better than that? And we're doing some work to try and measure that uplift in performance of our models compared to some baselines. That is a overview of the work. Basically, a lot of iterating. And so we'll try out different models. We'll try out different sets of features. We'll try out how we present those recommendations to eaters. And that drives a lot of how we do our product design. So I think I've left a lot of time for questions and discussion. So one thing, we're hiring, so I also have a pointer here. But if you have any more questions about the Uber Eats space or experimentation in general, I have some links here as well.